One day in the animal kingdom, so much rain, so much so that all the animals started running away. The lions, the emperors, the zebras, all of them were running away to find shelter. But the turtle, the tortoise, was actually moving very, very slow, as if he had nothing to worry about. So the lion decided to stop and then ask him, "Why are you not running as fast as everyone?" To the surprise of the lion, the tortoise said, "I don't have a reason to run fast." Why? Because I have my home with me. And indeed, when the rains came, the tortoise just tucked itself inside the shell and it was safe. What am I talking about? When you follow me, when you follow what I teach, you are going to be as safe as the tortoise in the exam, because I only teach the things that come in the exam. So today in Mathematics Grade 12, we're talking about algebra, and under algebra, I have discovered two concepts that always come in the exam. One in paper 2, the other one in paper 1. So what is factorization? So factorization, if you remember from my last video, Mathematics Algebra, I explained the distributive law, which looks like this. If say you have 2, and then in the brackets a plus b, the distributive law states that the 2 applies to both a and b, as in this can be 2 times this to give 2a, 2 times this to give 2b. Factorization, however, is the opposite of this. So if you have this under factorization, you have 2a plus 2b, we do the opposite of this. So which one is common? This part and this part, it's the 2. So we put the 2 out here. And then what is this 2a divided by 2? It's going to give us a. Then 2b divided by 2 is going to be b. So distributive law and factorization are the opposite of each other. Long story short, factorization is you getting a long expression and smooshing it, simplifying it to a small expression. Then, for you to understand factorization better, there's another concept I need you to understand, and this concept is called the difference of two squares. Normally, when factorizing, like I've showed you here, we find what is common between 2 or more entities. So in this situation, what was common was the 2, is what we put out here. And then we divide this by the common number. Then we get this. We divide this entity by the common number, we get d. There is another application, another method, another thing you need to apply for you to factorize completely. And this one is called difference of two squares. And it looks like this. Say you have a squared minus b squared. The name difference of two squares comes from the fact that this is a square, this is also a square. So two squares, a squared, b squared, two squares. And the word difference in mathematics means subtraction. So for difference of two squares, you need to have two numbers that are both squared, and you need to have a subtraction or a minus sign in between them. Now for you to work with this, what you do is you open up two sets of brackets like this. A squared means we have two a's there, so we get one a, put it here, the other one, put it here. Then b squared means we have two b's, one b here, the other b there. Then for the signs, you can put a plus here and a minus here, or you can switch them. You can put a minus here and a plus there. Just make sure you don't have the same sign. The sign should be different. And just like this, you have applied the difference of two squares. But there are situations where you have something like this. 9a squared minus, let's say 1. In this situation, How can you use the difference of two squares here? It's easy. Make sure these entities are squares. We can make 9 into a square by writing it as 3 squared, because 3 times 3 gives us a 9. Then the a squared like that, minus 1. We can also make 1 a square by just putting a 2 here. Mind you, this is the only number with which you can do this, because 1 times 1 is still 1, but 2 times 2 is not going to be 2. So for 1, you can just put the square there. So these entities, this side are both squares, even that side squares. Then we can apply this law, difference of two squares. So here 3, I have 2 3's, one here, the other here. A's, I have 2 A's, one here, another here. The ones, one here, another here. Then here I can put a minus, here I can put a plus. Now let's get to the examples. So this one is saying factorize completely 27y squared minus 3x squared. This is easy if you practice it enough. So the first one, 27y squared minus 3x squared. First step, ask yourself what is common in between these two entities separated by the minus. This side and that side, is there anything that is common? First of all, in terms of numbers, is there a number that can go into 27 and 3? Yes, it's 3. And for the letters, is there a letter that is common appearing on both sides? No. This side has y, this other side has x. So for this one, we just consider the number. You close it off like that. 27 divided by 3, that's going to give us a 9. So this is 9. And then y squared minus 3 into 3, this is a 1. 1 times this will just be x squared like that. We are done factorizing just like this. But if you remember that difference of two squares concept I taught you, this is not entirely complete. As in, we can use difference of two squares here. But remember, for difference of two squares, we need both these entities to be squares. Y is a square, x is a square, but the 9 here is not a square. So we have to change this to become a square. And of course, this is supposed to be a minus as it is. So this will be 3. 9 can be expressed as a square as 3 squared, because 3 times 3 gives us 9. Then this is y squared minus x squared, and close it off. Then here I'll get my 3, and I'll use these braces so that I can properly write the brackets inside. You can see them like that. So there are 2 3's here, 2 y's, 2 x's. So 1 3 here, the other 3 here, 1 y here, the other y here, 1 x here, the other x there. And I can put a plus here and a minus there, and I'm done. A question exactly like this will come in your exam. Let's go to number 2. So this one is saying 7x squared minus 7. For this one, what is common in terms of numbers in between this entity and this entity? It's 7. For the letters, there's only one letter on one side, so we ignore that. 7 into 7, this will be 1. 1 times this will be x squared minus 7 into 7 is 1. Again, we are done. But the second step is to do the concept for the difference of two squares. As usual, this has to be a minus. This is a square. 1 is not a square. So what we can do is we have to make that one a square. 1 is the special number where you can just put a 2 up there and it's a square. You haven't changed the number because 1 times 1 is still 1. So here I have 7 braces, and I do this. 1x here, the other there. 1 here, the other one there. Here minus, there plus. Again, we can switch these, because there it's minus plus, here it's plus minus. Here are examples 3 and 4. As you can see, they have a pattern. They look almost the same. So this one is 4a squared minus 16b squared. So for this one, we consider, or we ask ourselves, what is common? This side and this side. For the letters, there's nothing common. For the numbers, 4. 4 can go into 4 and 16. So this will be 4 out here, we close it off. This will be a squared, because 4 into 4, this will be 1. 1 times this, a squared, minus 4 into 16 is 4. So this is 4, and then we drop the b squared like that. Then, difference of two squares concept, we get 4. Maybe before I do that, oh yes, we can do this 4. This is a squared minus 4 is not a square, but we can make it a square by writing it as 2 to the power 2. It'll be like that. Then I get my 4 here. One a there, the other one there, 2 there, 2 there, a b there, and a b there. Plus here, here minus. Just like that, we are done. Example 4. For this one, we have 3x to the power 3 minus 27x. So for this one, ask yourself what is common. For the numbers, 3 can go into 3 and 27, so I put 3 out here. And the letters, I have x to the power 3 and x. So there, x can go into both of them. And close it off. 3 into 3 is 1. Then x into x to the power 3 is x to the power 2. Then 1 times x to the power 2, this will be x to the power 2, minus 3 into 27, this will be a 9. Then x will cancel with x, this will be 1, this times this is just 9, like that. Again, we are done. Now going to the next part, difference of two squares. This will be 3x squared minus that, changing it to a square, will be 3 squared. And then we do this, 3x this will be x plus 3, x minus 3. And just like that, we are done. This is the concept on factorization that you will find in paper 1. Let's go to the one that you find in paper 2. The paper 2 concept needs you to understand division of fractions, where you have a number over another, then you divide it. Let me show you what I'm talking about. If you have something like a, b over a, this a and this a can cancel, and hence, since a into a, this will be a 1, you'll be left with b over 1, which is just b. If this was reversed, if it was a over a b, this would cancel, and hence this would be 1, this would be 1 over b, and it ends there. So this, you'll see it will not be doing the paper 2 questions. Let's go to them now. The surprising thing is that for these questions, the paper 2 questions on factorizations don't say factorize. They instead say simplify. But when you see a fraction like this, you will know that they are asking you to factorize. So what do you do here? For this one, it's either you are factorizing the bottom part, the denominator, or the top part, the numerator, and in some cases, you are factorizing them both. It's easier to work with if you just get the part you need to factorize. So ask yourself this: is there a need for us to factorize the numerator here? No. But the denominator down here can be factorized using difference of two squares. So we get this part and just take it here so that we can deal with it individually. 81a squared minus c squared. So this is a square, this is a square. 81 is not a square. We can make it into a square. What is 81 as a square? It's 9 squared. And a is squared minus c squared. Now it's complete. This side, the entities are squared, and there's a minus in between. So for this one, as usual, 1 9 here, 1 9 here, and a C here plus, there minus, here done. So meaning this and this, same thing. So we can now actually replace this with this by writing this equation, this fraction 9a minus c, as in over 9a plus c, 9a minus c. Do you see anything common? Do you remember that a, b over a idea where these two cancel? Here I have 9a minus c, so this and this can cancel, giving me 1 over 9a plus c. And just like that, we are done. You will see this cancelling in every question of this kind. There's always you factorizing on the side, putting it back there, you cancel, then you have your final answer. Let me show you the second one. So x to the power 3 minus 9x. Sorry, I'm getting ahead of myself. Before I write this, let's ask ourselves, do we need to factorize the top part? Yes. Do we need to factorize the bottom part? No. So we take this top part on the side, x to the power 3 minus 9x. Can we use difference of two squares there? Not yet. Is there anything common this side and that side? Yes. What is that? X. There's x here, there's x here. So take the smallest power of x, so this is x to the power 1 or just x. This into this will be x to the power 2 minus x into this to cancel, this will just be a 9. Now it's looking closer to something we can work with using the difference of two squares concept. So for here, x squared minus this will be like that. We have now expressed the 9 as a difference of two squares when we write it as 3 to the power 2. So just like that, we can now do this. 1x here, the other there, 3 there, 3 there, plus here, minus there. Then we get the same thing and fuse it out there. So I'm going to write x. Sorry, I've moved the equation this side, but still you can understand what I'm trying to do. X plus 3. Then everything. So this thing replaces this top thing. So I get this, I put it on top, then here this comes at the bottom, plus 3, like that. This kind of looks like that. So this and this can cancel out. This will leave me with x minus 3, everything over 1. Now anything divided by 1 is as good as us forgetting about the 1, so this will be x minus 3. We are done. Okay, examples 3 and 4. I like example 3. Why? It's a bit more work. Can we factorize the top part? Yes. Let's put it on the side. So putting it on the side, this will be 3x to the power 3 minus 6x squared. Is there anything common on this side and that side of that equation? Yes. For the numbers, 3 can go into both 3 and 6. Then the letters, there's x to the power 3 and x to the power 2. The lowest power is x to the power 2, like that. So 3, this is 1. X squared into x to the power 3 is just x, so I'll remain with an x here. Then that side, 3 into 6, this will be 2. This and this will cancel. This times this, minus 2. So for this one, the top part will be 3x squared, x minus 2. Then the bottom part also can be factorized, x squared minus 2x. For this one, what is common this side and that side? It's x, so I put x out here. Then for the numbers, there's nothing else but the 2, close it off. This into this, x minus x into this. It's just 2, and we are done. Then we get this and put it down here. So this will be x minus 2. So this one was the one who was going to be difficult, but it's easier than the rest. So this and this cancel, remaining with 3x squared over x. Now, even these, they have something that is in common, x here, x there. So this one, this x. So the final answer is just 3x. The last one, 3d squared minus 27 over d plus 3. So 3d squared can be factorized. Minus 27. What is common? The 3. For the letters, it's just the d. So it's going to be d squared minus 9, because 3 into this is 9, and 3d squared minus the 9, changing it into a square, will be 3 squared, like that, and this eventually will be d minus 3, d plus 3. 1d here, the other one there, 1 3 here, the other one there. Then we bring that stuff here because we can't factorize this. So the top part will be 3 d minus 3 d plus 3, everything over d plus 3. D plus 3 with d plus 3, I'm remaining with 3d minus 3 over 1, which is just 3d minus 3. Do you now see how you can be that confident, slow-moving tortoise when everyone else is panicking? This concept will come in your exam. The first concept in paper 1, the second concept in paper 2. Why are you going to fail?